All right, good morning, everybody. Welcome back to class again. This week we're going to be talking about unit testing, and we can just come out here to Module 6, and I have a unit testing content folder or file, page, whatever we're calling it. But before you do that, make sure you've looked at exception handling. There's a little bit of reference to it in this unit testing video, so you need to have seen this exception handling first. Or I guess you can get whatever order you want, but some of it might not make a lot of sense. So we went in here to this unit testing content, just like that. And then we grabbed all of this. I've copied it already, and then we just go put into VS Code when I've got that over here, and I've done that already. My file over here, just so you know, it's not my app.py like normal. I created a different file. It's called drugdosing.py. And the whole idea here is that I've created a little helper file that will give some guidance and give some recommendations for drug dosing, perhaps a particular specific drug is the general idea. It's obviously not like evidence-based and actual stuff. This is just fake code that I've written just to illustrate our point. Okay. So this program, we're going to go through it a little bit here in a second, but it's moderately complicated. It's not very complicated. Real world code gets extremely complicated, with all the rules and all the conditions and all the loops and all the stuff that we're doing and all the outputs. There's lots of different paths you can take based off the data that's put in there, right? So if you're reading data, which is the typical way programs work, is you'll read data from somewhere like a database or a web service or a file or something. And then based off the data, you're going to have lots of different paths that the data can take based off what's in there, right? If you got data for a female, you got data for a young person, whatever the case may be, there's lots of different rules. And, based off the medications and allergies and everything, based off all that data, you can have lots of different paths happen. And then let's say you get your program working, it's set up fine, it's working, people are using it. But then something happens. Maybe a clinician wants a new feature added, or they want a slight tweak in the guidelines and the advice that it gives out, or maybe someone just finds a bug in your code and something just needs to be fixed. And so in this week, we're talking about unit testing. The question is, how can you go in to your complicated code and assure yourself and the clinician users that your code is still good, even though you've made this change, and that you're not going to be doing any patient harm, okay? And then you just have confidence that your code is working as it should. So that's the whole premise here, right? How do we make changes to our complicated code and make sure that before we push it out, that our code is working properly as it should be? And for that concept, it's very common and standard that we would do that sort of thing or have these sort of concerns in a production environment. To solve this issue, there's a whole subset of software engineering that's called unit testing. And so this week we're going to be talking about unit testing and how we can validate that our code is working well. Okay? So let's first look at the code that we have here just so you can get an idea of what we're seeing before we start. And again, this isn't anything real. This is just my 10 minutes of programming to come up with something to show you. So let's say we have a method. You can tell it's a method because of the def, the define right here. We're calling it drug dosing. So we're creating a method called drug dosing. And in this example, we needed to pass in the patient's age, weight, and gender for whatever drug this is we're worried about dosing on. Maybe it's Coumadin or something. That's a common one that people worry about. And then let's say we have all these guidelines. Let's say these guidelines come from some journal article published somewhere. And so we're just looking, again, based off gender, based off age, we're going to recommend some sort of dose, and it's different for males versus females. And likewise, it's different for geriatric patients. We want to cut the dose in half if you're a geriatric. Okay. So again, based off whatever data you pass in there, there's all these different paths that we can go through. And we just want to make sure that what changes we do aren't going to break these results, these outputs. Okay. So that's that one. We have another helper method here. Again, you know it's a method because that's the define or the def here. And this is called drug contraindicated meds. You pass in the list of drugs. It's going to tell you if any of the drugs you're taking are contraindicated for what we're trying to do here. Okay, and we just have a little basic counter. We're going to loop through that list. We're going to force the drug name down to a lowercase just so we can get accurate apples to apples sort of comparison. And then if it's equal to any of these drugs, we're just going to increase the counter. And then we just return that count, right? So pretty basic line of code there. Likewise, we're going to do the same thing for allergies. Again, they pass in a list of allergies, and if any of these allergies are in their list, we're going to assume that they're contraindicated and increase the counter and return it back to the patient. And then finally, we have this one larger method that's going to take in all of that data and churn out all of this stuff to give you a piece of advice, okay? The first thing we're doing here, though, is we're saying make sure they actually pass in data, right? They don't just hand us blank parameters. If they pass us blank parameters, we're going to raise an exception. So this is why you need to watch the exception video first before this one, so you understand what you're looking at here. We're just saying you didn't pass us any data to the method, we can't continue, right? So they didn't give us data, we're just going to raise an exception and be done. And then they can handle that on their side however they want to. But if they did pass us data, we're going to go call those other methods we just looked at, right? We're going to go say, how many contraindications do we have for allergies? How many contraindications do we have for medications? And then what is the drug dosing recommendation based for this patient? And then based off those three pieces of information, we're going to give some advice, okay? So if the allergies and the drug contraindications are both 0, then we're going to recommend giving a dose of whatever this dosing method said. And that's in milligrams per deciliter, so we're probably some sort of IV bag. And then we're saying if the allergy count is greater than 0, these are equal to 0, these are greater. So if we have a contraindication for a drug and an allergy, then we're going to recommend not giving this drug to the patient. And then maybe there's a special case where we say, all right, if you have just one, it's probably okay, but we'll start off with a half dose, right? And so we're just taking the dosing and cutting it in half. And in all the other cases, we're just going to say, go talk to your physician. They can decide what's best for you, right? We're not going to give you advice for it. Okay, so this is our program. There's 4 methods. And it's not very complicated, but there's enough different pathways that it can take, right? All the different dosings come out here, and all the different paths we have right here. We want to make sure that those things get tested and we validate that those paths are still working if we were to go in here and to make some sort of change, and that the right result is coming out of those methods if we make a change, okay? So again, to do that, we're going to need unit testing. So we're going to start with that. But I should say, before we start unit testing, our code needs to be formatted in a specific way in order to enable unit testing to work well. So think of functions that we get in mathematics where you have like the f of x equals to some algebraic equation. That's literally what we're trying to do here, right? So the f of x, right? The x part is the input parameter we give it. So when we write code or methods like this, it needs to have a way to accept parameters into it. And that's what we do here in our parentheses. We're accepting parameters in there, right? We're accepting parameters. And then again, on the functions, once it's done, on the f of x example, once it's done with its work, there's going to be an output. There's going to be a result. So all of our methods need to have a return that's saying, you passed me in something, I churn and do some work, and then I'm going to return you the result of that work. So we have to make sure that our methods that we want to test are set up in this manner, right? Pass in data, get a result. It's easy to write methods that don't do that, and then if we do that, we can't test those, right? So if we were to write something like, this is again, not a real example. If we were to write something like this, we could not unit test this method with any, we could call the method hello world, but we don't know what it's doing. We don't know what the output or the return is because we're just printing it to the screen. We're not returning a value to the caller, and we're not passing parameters in there. So there's nothing that's going to vary anyway. So there's really no reason to test it, right? So in this case, hello world is not something that we can test because there's no input, there's no output, there's no return value. But you can see all these ones that we've written here. There is input and there is an output. Okay, so that's the first step we have to do to make sure we can use unit testing, is that our code is structured in a way, that's this line right here, that we can do that sort of stuff. And if it's not, we need to rewrite it and think about how we're doing it, because that is honestly best practices anyways. If you were to write methods that don't take input or don't have output, you're typically relying on what's called side effect programming. And that means you're doing things that are with variables that you don't own in that method, things that are like global or higher level scoped, or you're relying on other things to be in place that may or may not be. That's called side effect programming. And that's usually a very, very poor paradigm or habit to get in. And so this is really the way we should be doing our methods in our code anyways. So just want to make sure we're all on the same page about that. Okay. So then what does it mean to actually test our code or to write unit tests, which is what we're doing this week? Okay. And it may cause some chagrin, but literally all we're going to be doing is we're going to write new code or new software that's going to let us exercise or test existing code or software. So it's sort of a little bit circular, software to test software, but that's what we're going to be doing. So think about, this might be silly, but I was thinking about this the other day that the vehicle emission testing is pretty much a unit test. If you think about it, right? You you take your car into the mechanic or the shop or wherever you go, the emissions tester. He puts your car up on some sort of dynamo where he can, gun and rev the engine without it going crazy. And then he puts a sensor in your tailpipe. And that's literally a unit test. He's got the input. He can alter, the engine speed and the RPMs that your engine is doing and how long it's running for. He's altering those things. And then he has something to capture the output of it, which is the sensor on the tailpipe. And it's giving you the number, right? The carbon dioxide number there at the end of the tailpipe. And that's literally a unit test. So that's kind of the idea of what we're doing, right? I mean, the car is its own thing. He's putting something around that car to capture the input and output. And that's what we're doing. We're writing software that's going to go capture the input and output and measure it to see if it's working well. Okay. And then again, when we write these unit tests, we want to write a lot of them. We want to be as specific as we can. We want to test as many different aspects as we can. We want to come at it from a lot of different angles as we can. And the more we do that, the more confidence that we'll have that our code is doing what it should and that it's working well. Okay. So let's talking about it a little. Let's actually just jump in and get some done. So to do this, create unit tests, we're going to need to create a new file. And again, this is the first time we've done it. So this means that the submissions that you do for this week's assignment or for the unit test assignment are going to need to be two separate files. So you can either attach two different files to the assignment turn in thing, whatever you call it, or you can zip them up into one zip file or 7z or WinRAR or whatever you want to call it, and just submit it that way. But the point is you have to make sure you get both of these files to me. Okay, so to create a second file, we come over here onto the left. So we come to our project. I'm still using my Hello Doctor one from, I think, week 1. I just keep reusing it. But yours will probably say something more accurate than that. And then you just come right here to this first thing that says new file. If you don't have that, you can go right up here, file, new file. I prefer to come down here. And then we're going to call it something very specific. Usually there's a pretty standard naming nomenclature for this sort of thing. Because Python projects, or just any software project in general, can have lots of different file names. Like we have drug dosing here, but there could have been like 15 other files in there. And so the standard nomenclature we do for something like this is we just do test underscore and then what it is we're testing. So I'm testing drug dosing.py. And that way it's going to look, you can tell what's happening right here, right? We're the drug dosing py and then the test drug dosing py. Okay, so we got a brand new file. It's empty. I've got some code here we're going to copy and paste in there. This is what I was just talking about right there. Okay, so now for the rest of this video, this stuff, we're going to have to cut and paste all of this stuff. See right here, I'm saying cut and paste all the below code into the new file. So we're going to take all of this stuff from line 124 down, and we're going to put it in the new file, and that's where we're going to pick up with the video. Oops. So I'm going to cut. Okay, so we just got all that here in this one, and then here in the new one, I'm pasting, and then we'll go talk about it. Okay. So we're getting rid of this. We can get rid of that. Okay. All right. So now in this file, we just have those 4 methods, right? With the inputs and outputs. The advise, the contraindications, and the dosing. That's all we have in here. So it's pretty small. It's just a helper class. It helps us check that what we're doing is accurate. Gives us some advice on dosing. Okay. And now we're over here in this new file. Okay. So the first thing we need to do in this new file, because we're trying to test that software over here in the drug dosing Python, is we need to import that. There's code that we want to test that's not in here, okay? And we haven't really talked about imports a lot. Import is just a way to pull in other external resources or external code that developers have written, other developers or ourselves or whatever. It's just a way to pull in other files, other pieces of code. And so now we're saying we want to go import the drug dosing. You can see right here, the drug dosing code. And all that's going to do is in the background, it's going to pull in this file so that we have access to it. We want to be able to test that code, so we got to pull that code in and give us access to it. The other thing we need to import, in Python has a standard library called unit test. So we're just going to go ahead and import unit test. It's a standard framework that Python's written for us. And there are more than one frameworks. I'm just showing you the built-in one to Python, but there's, I don't know, at least a half a dozen other different unit testing frameworks that you could use if you prefer better. But this is the easiest one to get started and working with, in my opinion, mostly since it's already here and installed. You don't have to go grab any other external resources or anything like that. So this one's the easiest one for us to get started with. Okay. And then we're going to need a few more lines of code here just to make this whole thing work. And it's going to be stuff that we haven't talked about before. It's specifically this line 18. We're creating a new class. And we haven't talked about classes yet. That will come up in object-oriented module, which is here in another, I think, like 2 weeks. So you don't need to know what this line is doing per se. I'll explain it, but it's okay if you haven't seen it because we haven't talked about it properly yet. But what we're doing here is we're creating a new class. And again, we started with the word test. I just called it whatever. I called it test dosing. I could have called it test drug dosing or whatever. So we started with the word test typically, and again, because these are tests. And then in the parentheses, this is just saying that we're extending or inheriting from a test case. So we're going to this unit test library that we we imported on line 8. And then we're specifically looking for the test case class. And so we're just saying inherit test case into this test dosing. And then we have these colon here at the end. And then that means everything that's indented underneath this class is going to belong or pertain to this class, just like we did with our else, our ifs and our for loops and our methods with the def, right? Anything that's indented underneath it is a part of it. Same thing for this class. So we're going to indent everything underneath this, okay? And then now we can start writing our test cases. And the question is, what should we test? Or how do we test it? How do we know when we're done testing? How do we know we've written enough tests? So there's a whole paradigm or way of thinking about this. I'm not going to go into a ton of detail about it because, again, I think it's a little bit more complicated than we're trying to do in this class. But I just didn't want to do you a disservice by not talking about it. And then anyways, there's a pretty standard methodology out there called red, green, refactor. And here's a link if you want to go look it up. But this is something that comes up, this red, green, refactor is something that comes up when you're doing what's called test-driven development. So in this case, we wrote the code first, right? That drug dosing file, we wrote it first. And now we're going to go write tests for it. In test-driven development, we do the exact opposite. We know the requirements, right? We'll get our requirements from our analyst or from the clinician or from whoever is sponsoring us to write the software. They know what they want. They tell us how to do it, right? So we have these requirements. And in test-driven development, the very first thing we do is not write the code, but write the tests. So for example, if we knew we should have half doses for geriatric patients, right? That might be a requirement. It'll say whatever the dose was, cut it in half if you're over 65. That's a requirement. What we do in red-green refactor under test-driven development is we first write a unit test that's going to fail. That's what it means by red. If anything goes red in unit testing, it fails. So we write a unit test that's going to fail, right? It's going to be something like test geriatric dosing. And then we're going to write some code in there that would call a method that doesn't exist yet and has an output that doesn't exist yet. Okay, so we write the test first. It's going to fail. It's going to be red. And then the green part is now, since we started with the test first, we have to actually go write the code that supports it and would make it work. So now we go into our drug dosing file and write a method that would just cut whatever drug doses in half if you're a geriatric patient. And once we finish that, we run our tests again. It should succeed. It should turn green. Okay, so that's the red-green part. And we do that for all of the requirements. And once we start layering these requirements together, we'll start to see patterns where we can combine things together, right? So, for example, we don't, in our example, have a method that just cuts doses in half for geriatric patients. It's built in to another method that does a few other things, right, with the age and gender. So once we write all these tests, we get them all red and green. The very last step of that is called refactor. And just like it sounds in math or whatever, right, we're going to go group things together and rewrite some of our code. So for example, in the geriatric dosing, we might, like we ended up doing on ours, put it in one method that does 4 of those different things together instead of 4 separate things. It does 4 things at once. So that's the idea of refactor. So it's making our code look better and cleaner and more efficient. So that's the idea of red-green refactor. It's a little bit more advanced, and it's not something we need to do for this class. I just wanted to explain it to you because there are standard ways of thinking about unit testing. Yeah, and it really just flips test writing on its head where you do the test first and the code second, where in our case we have the code first and we're doing the tests second. Okay. But for our class, I think a good general pattern is what I've written here instead. Okay. So we're going to write, so we have these methods, right? We had 4 different methods in our drug dosing Python file, 4 different methods. And in order to make sure we're covering those methods with tests properly, we need to think about these 3 different things and write tests that will address these 3 separate things, okay? So we need to write a test that calls our method with good inputs and validates the output. We need to write a unit test that covers our edge cases. And what do I mean by edge cases? Edge cases are things by you as a programmer would look at the code. You're going to look in there and see what code's in there. And you're going to want to test things where you think it might have issues with. And these are edges. For example, loops. You want to make sure the test handles an array or a list with a lot of data. You want to make sure it can handle it with no data. That might be an edge case, right? Does it happen and still work? Does all your logic still work if they passed in an empty list or empty array? What happens if you pass in a list with some of incongruent sort of data? If it's expecting strings, what happens if you pass it in an array of integers? Does it handle that, right? These sort of things are edge cases. Or if it's doing any mathematics in there, any calculations, an edge case might be passing in a positive number like it should, normal case. What happens if you pass it in a negative number? Does it still work? What happens if you pass in a 0? Does it still work? What happens if you pass in a letter instead of a number? Does it still work? Right? These are the sort of like edge cases we're talking about. It's you purposely trying to see that the program is working with possibly bad data and that your thing should still happen. And then finally, number 3, we want to purposely write tests that should fail and should cause our method to fail or to raise an exception. And we want to validate that it's working that way as well. Okay, so just like we saw right here on this drug dosing, where was it? Right here on our advice, we purposely raise an exception if they don't give us good data, okay? So we want to write a test that makes sure we get an exception when we should be getting an exception. And that's what I'm talking about here with number 3. And then we would do that. We would repeat these steps 1 through 3 for every method in our code. And this might translate not just to 3 separate unit tests, might translate into 100 different unit tests. I have plenty of files. I work at Intermountain Healthcare as a software engineer, and I have for like a decade now. But I have plenty of files where I have way more code, way more unit testing code than I do actual code. I'm thinking of one. We did something with the problem lists, and there's a lot of different edge cases we did for the NICUs on these problem list keeping lists of diagnoses. There's just a few methods, but it's some complicated logic that we do there. And I ended up writing, I think, over 210 different unit tests to test that code, because there was a lot of different conditions and paths and stuff. And thinking about that, again, right here, we have all these different paths, right? So we might want to write a test for the advise method and give it all the data that it needs so that we can make sure this condition is hit. And then we'll write a whole separate test passing in different data to make sure this condition gets hit. And we'll write another test with different data to make sure this condition gets hit. And then this condition, right? So just to make sure that all 4 of these paths get hit, we would have to write 4 separate unit tests passing the different data necessary to get each of those paths. And similar up here, right? If we want to test that this actually gets hit in the proper way, we'll have to call drug dosing. We'll have to pass it in the right data to make sure that this gets hit. Then we'll write a whole separate unit test to make sure that this path gets hit, that this path gets hit. You understand? So you can see we're not just going to write typically 1 unit test per method. This one right here, we would write probably like 10 or 12 standard unit tests just to make sure all these paths get hit. And then we would start writing a bunch of tests to pass in bad data to see what it does, the edge case data to see what it does. And so just for testing this drug dosing, you could probably easily write 25 different unit test methods. Okay, so that's the idea of what we're talking about here with this 1, 2, and 3. And then we would repeat that for every method, right? So we might write 25 tests just for this drug dosing. We might write 25 tests for this one, 10 or 15 for this one, and then like 30 tests for this one. We're just trying to make sure that every aspect of it is getting hit and tested. Okay? So now that we have sort of an idea of what we're trying to do, let's actually just jump in and do it and show you what a test looks like. Okay? So we're going to write one for that first method, the drug dosing. I've already written these because I didn't want you to have to sit here and watch me type them. So all we're going to do is going to write methods, right? So we have this class right here, this class called test dosing. It extends this test case class from the unit testing library. And now we're going to write our own methods that test our other methods, okay? So we write a def or define, just like we do for methods. And then we test what we're going to test. So there's a requirement here on line 38. So our test methods have to begin with test underscore. That's a requirement for this test to work. If we don't have the test underscore, it won't run and it won't work for us. That's just a requirement of the library that they're imposing on us. So typically you just say test underscore, and then you give it the name of the method you're testing. And then you might even get more specific, right? So I could say test drug dosing, and I could do underscore geriatric case, or female 250 case, or exception case, right? You can go a lot more specific on these method names than I did. These are just examples. And then we have to pass in, again, this is going to be a requirement since we're using classes. We haven't talked about classes or instance variables or static variables or anything like that. So I'm not expecting you to know or understand this until we talk about it. But we have to pass in this keyword self into these methods. And that's just a way to get a reference to the instance of the class that our unit test is running. And again, you don't need to know what all that means. Just know that it has to look like this. And again, just like all our methods, we indent in a colon, and then everything that's indented underneath it is going to be a part of it. Okay? Okay. So now we have to actually do some work in our test method, right, in our unit test. We got our class up here, our test dosing. We got a method. We're going to test our drug dosing method. Now we got to actually test our drug dosing method. We've actually got to do something here. Okay. And so the idea here is we want to call it. And so remember all the way up here on line 4, right there, we imported drug dosing, right? That was just this file over here. We imported it, and that lets us use it. But before we can use it, we have to call it by a specific thing. Since we import it called drug dosing right here, you can see it's got these curly braces. Okay, so we imported drug dosing, then we hit the dot, this period, and then it gives us all the things that is in that file that we can use, okay? And you know we had those 4 methods in the drug dosing file, and here it is, it's listing those 4 methods for us, okay? So we're gonna go to the drug dosing file. We're gonna call the drug dosing method. These are poorly named on my part. Ideally, they would be different. And since it's a method, we have to use the parentheses to pass parameters into it. And as soon as we start that, it shows us what parameters it's expecting. The first one is an age. It doesn't tell us the data type. I'm just going to assume it's an integer. Then we're going to pass in the patient weight. And again, it's not telling us units or anything. I'm just going to assume kilograms. And then the gender. And again, it's not telling us what it should be. I'm just going to assume it's M or F. Okay. So this is us calling the unit, passing in different data, but we need to capture the output. And for that, we just store it into a variable. Okay. So I wrote a bunch of different ones here randomly. We're calling that method, was this like 5 or 6 different times here, passing in a bunch of different parameters. And then we were capturing the results, okay? So that's the first part of a unit test, right? We actually got to call the method, and we got to vary the input, and we store the output of it. But now we actually got to test to see if it's producing the right output, okay? So based off this input, what should the output be? And then we just ask it, or we just verify that it is the right output. Okay, so it's pretty simple, or it can be simple, okay? And if the output that we get here, right? So if we call the drug dosing with these parameters, and we know what the output should be, we're going to do tests for it, right? We're going to do some checks, some if statements, right? Or whatever we would do to double check it. And if it's giving us the right results, our test will pass. And if the results it gives us back are incorrect, then our test will fail. And then we'll know if our method is working properly, okay? So we have a few different ways that we can do this. Here's another link. I'm just going to go show it to you. Let me copy it. We have to make what are called assertions in unit tests. Okay. So when we make assertions, these are going to be very similar, if not identical, to our if statements that we've done, our Boolean logic, right? If some value is equal to another one, do something. If a value is not equal, if it's greater than, less than, whatever the case may be. Okay. But we're not doing it in if statements. Instead, we're doing it in these little helper methods that the unit testing framework gives us that we're inheriting from. Okay, so the one I'm use here almost exclusively is assert equal because that's the easiest one to think about. But just know that there's a lot of other options, and as you get more advanced, or if you want to do more complicated things, you can use those. Again, for this example, I'm only using 2 of them. I'll show you this first one I use a lot, and then there's another one I use a little bit less. But it's really easy to think about. If 2 things are equal, the test pass, and if they're not equal, the test will fail. So that's what I'm using here for this class. Okay, so we executed all these 6 methods, and then we just come down here and we make some assertions. And these assertions have to be accurate, otherwise the test will fail. Okay. And then we start these assertions with the word self. This comes from right here. We passed it in, or it was passed to us, I guess I should say, automatically. And self is just a reference to the instance of this class. And again, you don't need to know what that means, because we haven't talked about it yet. Just know that in order for this to work, you got to type self dot. And then these are all the assert examples, just the ones I showed you on the other web page a second ago. So we want to make sure that something is equal. Okay. And so what we want to make sure is equal is we take the result. This is the new one I just wrote, right? And then we want to make sure that it is equal to some other value. I don't know if that's actually the right value it should be or not. But this is all we're doing, right? So we're saying make sure that the output of that method is equal to this. Is the output of that method equal to this? So we're doing a bunch of tests right here, right? We're doing 6 different, we called that method 6 different times with a bunch of different varied input. And we want to make sure that all the output matches. And I don't actually know if that's the right one, so I'm going to delete it because I don't want this to fail. And I'm going to delete this up here because we don't really use it. Okay, so we're doing 5. We're doing 5 different ways of calling the method, and we're making sure that those 5 results match. And that's it. That's all we had to do. So this was a handful of line of codes, right? This is literally all we're doing is these 5 and those 5. And it could be smaller. It could have been just 1 or 2 if we're testing a very specific or narrow case. Okay? So this is one unit test. This test of drug dosing. One unit test. Okay? And if any of these 5 asserts fail, the whole test will fail. Okay? They have to all succeed for this one test to succeed because that's how we've written it. Okay? So let's look at another one. This is a slightly different one, but you can start to see the pattern that we're doing here. Okay, so our test methods in a unit testing framework has to start with a test underscore, has to. Otherwise it won't run. And then we say, what are we actually testing? We're testing the drug contraindicated meds. And then again, we pass in the instance of the class reference to it. And now all we got to do is a couple of things, right? We just need to call that method from the drug dosing file. We're calling the drug contraindicated meds method. And then that is expecting a list of meds. So I'm passing it in a list. This just happens to have one item in it. This is called Zithromax. This one's amoxicillin. This one has a couple in it, right? We got penicillin and Xanax. And this one has 3 of them, okay? So again, we called the methods. We had varied input. We captured the output into a variable. And now all we got to do is just check. Are they equal, right? Did the output of that method equal what we would expect that method to produce, right? So in this case, there should have been no contraindications. There should have been no contraindications. There should have been 1 contraindication, and there should have been 2 contraindications in this case. And again, all 4 of those calls have to succeed and pass before this method can pass the whole thing. Otherwise, the whole method will fail. And we're going to go through these. We're going to debug some of these just to show you what it looks like when we run them. I'm just trying to show you the code first so you can see what is happening here. Okay, and then finally, I think this is our last one. Well, okay, there's actually 2 more, but this is the last one we do on the main methods here. We're going to test the advise method. Put a breakpoint there. Okay. We have more methods than this, and we could write a lot more tests. I'm trying to keep it simple for what you're trying, just for this video, but we can go a lot more complicated than this. So we're going to test the advise method. So again, it has to be test underscore, and then we pass the self-reference into it. And we go to the drug dosing file, and we're calling the advise method. And then we pass in all the parameters that it's expecting us to. And again, we do that 5 different times with 5 different varied inputs. 5 is random. It doesn't have to be 5. It could be 1 if you know what you're testing specifically, or it could be 1,000, or you could write whatever you need. I just did 5 here for brevity and just to give you a few examples to show you what we're doing here. So again, we're passing varied input like our f of x example, and then we're just storing the result into a variable of what happens out of that method, and then we're just comparing to make sure they're the same. And so this one, the test advise, these other ones up here are passing numbers, right, or floats, right? The dosing is floats, the contraindications are integers, and then the advise is testing strings. That's why I did these 3 methods, because they're varied output types. And again, I'm just using the assert equals on all of these just to say, is what the output of this method equal to what I would expect it to show? And then if it is, the test pass, and if it's not, the test will fail, okay? So that's all we're doing. Based off these inputs, this should be the output. And then we say, yeah, is it true or not, okay? And so these ones are for normal cases, right? We passed in just normal data. And again, we would want to write cases for edge cases, which we talked about a little bit ago, right? How do you handle bad data, bad input, missing input, things like that, these edge cases where you think the program might have an issue. And I wrote an edge case here. I just wanted to show you this. So this is the drug dosing method again, right? So we're starting with a test underscore, it's required. And it says we're testing the drug dosing method. And then I said, this is an edge case for the gender, okay? And why did I think gender might be an edge case? Let's go see. The drug dosing, right? So we have drug dosing. One of the things they pass on is the gender. You can see here we do some. If it's a male, do something. If it's a female, do something. And in all other cases, do this. And so I wanted to see what would happen if I passed in genders other than male or female. Okay. For example, if you had a T for transgender, what if you had a missing gender? You just didn't pass a gender at all. What would happen? What if you passed a lowercase m and a lowercase f instead of the uppercase m and the uppercase f? So hopefully this highlights a little bit about what an edge case should be, right? We know what kind of input it's looking for, and we're going to try to break that. We're purposely trying to find bad input that could break our code, and we're testing for it. And that way, we're the ones who find the issues as the programmers. We don't want our users or our doctors finding these issues, especially because it could lead to patient harm, right? We could have something go wrong in our code that gives the wrong dosing advice, and we've got a whole world of trouble now if our program is not working 100% accurate, and they use our program to find out what the dosing advice for this drug should be for a child, and our code is flawed in some way, and we don't know about it, and it's been giving out wrong dosing advice, for weeks. There could be patient harm done, and it's very serious, right? So this is why unit testing makes a lot of sense. We need to be 100% sure that our code is working as it should. And so we're purposely testing these test cases, right? What happens with bad data, no data, unexpected data, normal data, and we got to make sure that it's just working as it should, okay? And so you can see we're doing that here. We ran it 6 different times, and again, we're testing to make sure it's matching the output we would expect in all of those cases. And then finally, there's one more test that I wrote before we run this. I just want to explain the code to you. On that 1, 2, 3 step we did up here, we should test these 3 things. We just did 1 and 2, right? We wrote tests that take normal input, which were those first 3 cases. We just saw the test case for the edge, right? We saw the gender, the male, the female. And then finally for number 3, we want to make sure the exceptions are raised when they should be raised, okay? And we saw that over here. Oops. Oh, sorry. We saw that over here that the advice method raises an exception, and that's normal. We want it to raise an exception in certain cases. And so we just want to test that these exceptions are being raised when they should be raised, because that's important also, okay? And so to do that, we have something slightly different, and that's going to be this one. So we're going to create a test that tries on purpose to get these exceptions to happen. Okay, so again, we start our test case with the test underscore, and then we're naming it the method we're calling, which is advise, and then it's just exception, right? So I'm testing the advise exception. Again, we pass self to it. And we saw what was needed to make that advise exception be raised. And so we're going to pass in the data that should make that happen. But to do that, our asserts are going to look a little bit different. It's something called, up here we've been using assert equals. Are these 2 things equal? The input, the output and the expected output. Are these things the same? For the exceptions, we have something called an assert raises, and it's slightly different. So we're using this with keyword, which is also probably new. With is a context manager. It keeps context within whatever line is or code is indented underneath it. So it's just saying whatever's underneath that is what's going to apply. So we're saying we want to make sure that an assertion gets raised, and this is the specific exception that we're making sure gets raised. It's an attribute error, and that's what we're raising here, right? We're raising an attribute error. So I want to make sure that when I call this method, I get an attribute error when I call that method passing in this specific data. So I'm calling the drug dosing file, I'm going to the advice method, and I'm passing in the data that is going to, in my mind, make this exception happen. And if it happens, this test will pass. And if it doesn't, this test will fail. Okay. So I'm going to put a breakpoint here. And then this one's slightly different. Right here. Okay, so this one is another test, unit test. This one's test underscore. We're testing the advise method. We're testing for an exception. And this time we're trying to get it to fail. This is just to show you what it looks like when a unit test fails. All these unit tests I've written so far will succeeded. I wanted to show you what it looks like when a unit test fails. And so the only difference here is I'm expecting it to raise an error, but it won't actually raise an error because I'm passing 1 in there, and I need to pass in an empty string. So this unit test will fail on purpose because I wanted to show you what that looks like. Okay, and then the final one right here. I wanted to show you what it looks like when I've been saying it every time, right? All your unit testing methods have to start with test underscore in order for them to be ran and executed. I was going to show you, this is just to show you what it looks like if you don't use the test underscore. I just have a unit test method called advise testing. And again, I am calling that method, storing the output, and I'm doing a test. Are those equal? And so I'll just show you what that looks like when we run it. Okay. And there's one other thing. You need to make sure that you have this in your code. There's a couple of ways you can run these unit tests. What I've written so far without this section right here can run. I would just have to go to the terminal window, or I'd have to save my Python file. I'd have to go to the terminal window and type in some commands to get the program to run. But I want it to run here in my Visual Studio Code, in my VS Code window, and to show up in my output terminal window. And it doesn't know how to do that automatically, so we have to give it a little bit of help here. And so we have to write this code, and you see it's not indented underneath the class file. It's all the way aligned left. And this is just saying, and again, you don't need to worry about what it is. You don't need to have to memorize it, and you'll probably never need it again. I'm just giving this to you for free. This is just saying when this program is ran, it passes in a main param. So classes have main methods, which is what they do when they're ran by default. The test cases don't have one, and so I'm just writing a little bit of code here to help move it along. I'm just saying if this program is ran and they're looking for the main method, which is what will happen when Visual Studio or VS Code runs it, if that happens, then I'm just going to invoke or initiate the first method in the unit testing framework, and that's going to spawn this whole thing to work. Okay. So we're going to do that. I put breakpoints on all of the tests so that we can see what will happen. Making sure I got all my breakpoints. Yeah, just so we can make sure or see what's happening. Okay. So I'm going to save it. I'm going to hit Control S, and then I'm just going to run this, hit F5. And again, since I put that last line or last chunk of code in there, it's going to work in VS Code, and it's going to work down here in our window. Okay, so I hit F5, and I have to be focused on this test file, right? If I was focused on the drug dosing file and I hit F5, probably nothing's going to happen, or it's going to, it's going to be in the context of this code. But we wanted to run this code, so we had to make sure that this file was open and selected. Okay. Okay. So we start running our first test. This is what self looks like. I just wanted to show you. This is the instance variable here that gets passed around with self. Okay. So we're saying call this method, drugdosing.advise, pass in that stuff. If I hit F11, it'll step into that code. Now it jumped over to the other file automatically. You can see that it's passing in all this data. And again, the control focus, the little yellow arrow line stuff, you can see what it's doing. I'm skipping over all that stuff. And then based off of those inputs, these are what it's going to output. It recommends giving a dose of 0.01 milligrams per deciliter. It returns that. And we got it here stored in our variable. We recommend giving a dose of 0.1 milligrams per deciliter. And we're going to do that a few more times. I'm hitting F10 to step over those. Okay, so all these variables have something different in them, right? So this one is similar. This one, oh, here's a different one. We recommend giving a dose of 0.025. And that's because this one is a geriatric patient, right? And they cut the doses in half, I think. So it's a 100-year-old person. This one says consult your physician before taking this medication. Trying to see if we have any non-recommends. I don't think I have a test case for that. So we could have written more test cases where it says we'd recommend you don't take this drug, but I didn't do that, I guess. So now we're just going to say, are these equal, right? So here was the output from the first time we called the method. And here's what it says. It recommends giving a dose of 0.01. And this is what we would expect it to do based off all the rules, right? So independent of that method, we came up with what the right answer was. And now we're just making sure that what the right answer was matches what the method did. Okay? And since it passed that line, it means that those two are equal. Otherwise, the whole program would have stopped and the unit test would have failed. So there we go. All 5 of those passed and succeeded. And I don't think it's showing us the output yet. No. Once all the tests ran, it's going to show us how all of the tests performed. Okay. This one is our exception. So we're going to make sure that this attribute error exception is raised when we call that method with this. And if I hit F11 to get in here, it steps into this method, passes all the stuff, and you can see right here it's about to raise this exception. No data passed to method. And it passed. As far as we can tell, it didn't explode or the program didn't have the big red box or stop running or anything. Okay, and then this one should fail. I purposely wrote one that should fail, just so you can see what it looks like. Okay, so it went and did all that. I hit F10. I should have hit F11, but I hit F10. Where was it? Down here. This one. I hit F10. I didn't step into it, but it did not raise an exception. And so I'm going to show you. Oh, here it is. The output starting right down here. So this very last line, I didn't see it, I guess, because it's pretty tiny. But this very last line is showing you if there's a dot. Trying to find a way to make that bigger. If there's a dot, it means that the test passed. And if there's an F, it means that it failed. So this means the first test passed, the second test passed, that third test we just ran failed, which is what I was purposely doing that. It's called a fail test. So that one failed, okay? Now we're here on this test case, testing the allergy contraindicated medications, I should say, not allergies. And then there should be 0, 0, 1, and 2. And then that test passed, right? So we have this dot added. So we have dot, dot, F, dot. Okay. So that one failed, or sorry, passed. So we've had 3 of the 4 pass so far. And now we're doing drug dosing. Again, the same thing. We call it 5 different times. We want to make sure that it is equal to what we would expect it to be equal to based off of our requirements and our rules. And that one passed, right? So we have 2 pass, a fail, and 2 more passes. And now we're doing some edge cases, right? These are the gender ones. What happens if we have weird genders, weird cases, weird whatever passed in? Okay. And then we're just going to go make sure that they're equal. Is this equal? Is this equal? Okay. And it finished running all the tests. That's all there was. I'm just going to hit F5 to end it. So it ran all the tests. So we can look up here. It ran all the tests. 5 of them passed. 1 of them failed. And so what it's going to show us here is the one that failed. And then it gives us the name of that method that failed. Okay, so we know that it's this test advised exception fail. And it's going to tell us right here. We said that there should be an assertion error. And it said that that error we wanted, attribute error, was not raised. That exception was never raised. And that's why the test failed. And it says we ran 6 tests and there was 1 failure. Okay, so now let's go see what it looks like when all our tests pass. I'm just going to get rid of this one. We don't even need this one anymore. I've just had that as a demonstration for you. So we hit F5, save it, hit F5. And now we're going to show you what it looks like when all the tests pass. So I'm just going to hit F5 a whole bunch of times just to run all the tests. Okay, now here's what it looks like. Now it's showing 5 dots, saying we ran 5 test cases and none of them failed. We're okay. So all 5 tests ran okay. That's all it's telling us. Okay? So that's it. That's all we got to do for unit tests. It's just a different way of thinking, right? But you can see that we're writing software to test software. Okay? So now let's see. So here's the whole reason, right? Why did we do that? When we first write our code for production or whatever, it should be perfect, right? Before we ever send it out and let doctors use it, our code should be great. Our code should be perfect. Okay? We put a lot of time and effort into it. And that's true. That's usually how it works. The time we get like real power and benefit from unit testing is not the first time we release our code. That's usually when it's pristine. It's after we've had our code in production for a while and somebody wants a new feature, they want us to go change something. Maybe the dosing guidelines have changed. There's new scientific research that says, oh, we actually need to use these dosings, or someone wants a new feature, or someone found a bug in our code, right? So after like a few months, we're going to need to make quite a few changes to our program. And this is where unit testing comes in, okay? Let's say you get a different developer using this, trying to take over and write these changes who's not familiar with it, or just us as the original developers, we're writing it and we have to make quite a few changes. The power of the unit testing framework is that we can go make that change without really thinking about it. We just go make the change. And then we just run the unit tests to make sure they all still pass. And if our unit tests all still pass after making a change, we know our code is good as long as we wrote sufficiently good unit tests, right? We don't need to go spend 5 days testing the input and the output and making sure everything's okay after we make a minor change anymore. Now that we've got this unit testing framework, this whole library of tests that we've written, we can just go make a change and then run our tests. And if our tests pass, our code is good. Okay, so I want to show you what that looks like. So we have this whole testing library right here, right? We can go make a change in here, and I'm gonna try to purposely make a change that would break our tests, right? So maybe a new rule came in that said, I don't even know. Let's say, I don't even know if this is going to break anything, but let's say the weights have been changed to 50 and 100. And in one case, instead of using milligrams per deciliter, we're going to use grams per deciliter. I don't know if this is accurate or not, but let's say, okay, so some new requests came in. They're like, all right, we need you to go change these 2 things. We just changed those couple of things. And now we want to make sure that we didn't break anything with our code, right? So we did that, and now we can just run our tests after making those changes. And let's hit F5 just to get out of all these tests. Okay. Scroll down to the end. And okay, look, so we made the change to the code, and our unit test said, oh, you have some failures, right? We ran 5 tests. 2 of them have failed. And that's a problem, right? This is what unit testing is for. It's going to identify when we've made a breaking change, okay? The first thing that failed is we tested the advice method right here. It was expecting you to have this output and you didn't. And that's because we changed it from milligrams to grams. And then likewise, this test failed. And it was expecting 0.1, and instead we got 0.05. See, so that's the power of what unit testing is, okay? It lets us keep our code pristine and tight. And then we have to now once we see that these have failed, we got to think about it. We got to say, okay, did I break something that shouldn't have, been broken, that should be working with these new requirements? Or do these requirements now require me to go update my test cases to make them match the new rules? And that's the idea with what the power of unit testing is going to do for us, and how we can assure that our code is pristine and it's not going to cause harm to our patients or anything like that. Okay, so that's the idea of unit testing. I hope that's helpful. I think it's pretty interesting personally, and I hope you guys get some benefit out of this